Hello everyone. Today discuss physical and mechanical properties of steel structure. First of all, structural steel. The steel used for structural works shall conform to IS 2062-2011. Hot rolled, medium and high tensile structural steel. Second point, most commonly used grade is Fe 410. Following are few physical properties of a structural steel as per clause 2.2.4.1 of IS 800/2007. Unit mass of steel, that is density, is equal to 7,850 kg per meter cube. Modulus of elasticity, that is equal to 2 into 10 to the power 5 Newton per mm square. Poisson's ratio, generally taken as mu is equal to 0.3. Modulus of rigidity, G, generally taken as 0.769 into 10 to the power 5 Newton per mm square. Coefficient of thermal expansion, that is alpha, is equal to 12 into 10 to the power minus 6 per degree C. Now, mechanical properties. Following are most important mechanical properties that are frequently used in design of a steel structure. Yield stress, ultimate stress, minimum percentage of elongation. Dear student, here see yield stress and ultimate stress. Both are different. The maximum value of stress is known as ultimate stress. Beyond the ultimate stress is known as yield stress. The properties can be obtained by performing tensile test of the steel sample. Mechanical properties of structural steel products, table 1 of IS 800/2007. Grade of steel, yield stress, ultimate tensile stress, and elongation percentage. First one is the Fe 410. Thickness is less than 20, then yield stress is equal to 250. Thickness is equal to 220 to 40, then 240. When T is greater than 40, then 230. And ultimate tensile stress 410. Elongation percentage 23. Again, Fe 440, T is less than 20, then yield stress 300. When T is equal to 20 to 40, then yield stress 290. When T is greater than 40, then yield stress is 280. Now ultimate tensile stress 440 and elongation percentage 22. Now Fe 490. When thickness is less than 20, then yield stress is 350. T is equal to 20 to 40, then yield stress 330. When T is greater than 40, then yield stress 320. Ultimate tensile stress is 490 and elongation percentage is 22. The last is Fe 540. Yield stress when T is less than 20, 410. T is equal to 20 to 40, 390. T is greater than 40, 380. And corresponding to ultimate tensile stress 540 and elongation percentage is 20. Now, some other important mechanical properties of steel. First one is the ductility. It is defined as the property of material by virtue of which it undergoes large inelastic, that is permanent deformation without loss of strength under the application of tensile load, that is known as ductility. And second one is the hardness. It is one of the mechanical properties of steel by virtue of which it offers resistance to indentation and scratching. The hardness of steel is measured by Brinell hardness test and Vickers hardness test and Rockwell hardness test. Now third one is a toughness. It is one of the mechanical properties of steel by virtue of which it offers resistance to fracture under the action of impact of loading. Now toughness is equal to the ability to absorb energy up to fracture. Before fracture, toughness will be considered. Toughness is generally measured by the area under the stress state curve. Now last is the fourth point is the fatigue. It is defined as the damage caused by the repeated fluctuation of stresses which leads to the progressive cracking of the structural element. Now, damage and failure of the material under the action of cycle loading. Fifth point, resistance against corrosion. It is very important term. Corrosion is the very important term for the steel structure. In the presence of moisture, air, corrosion of steel is an extremely important aspect. Now, to avoid corrosion, paint or metallic coating may be used. Now, few important terms associated with structural steel. First one is the residual stress. Residual stresses are defined as the stresses which are locked into component of assembly of parts at the time of rolling of steel sections, fabrication of steel members. They are subjected to very high temperature and after that are allowed to cool, which is basically an uneven process. Due to this uneven heating and cooling, residual stress in the structural member is generated. The second one is the stress concentration. Stress concentration indicates a highly localized state of stress at a particular location of a member. Generally, if there exists an abrupt change in the shape of the member, like in the vicinity of notch or holes, and the stress generated at that location is several times greater than the stress that would generated without that sudden change in geometry. Okay, thank you.